Okay, second video talking about this proof by contradiction. Shout out to Klara. You convinced me that this is a valid technique. I had to think about it, but I do find that this is logically valid. So we still assume that we're going to do proof by contradiction. So we still assume that contrapositive. So assume that m squared plus 8n minus 11 does equal 0. And then we say, okay, let's factor it. So we say m minus 11 times m plus 1 is equal to 0. Or you have to consider the possibility that it's m plus 11 and m minus 1 equals 0. Those are the two ways that you can factor it over the integers, because you're going to need to find the factors of 11, which is a prime number. And so you really only have these two possibilities. And in either case, what this comes out to be is m squared plus 10m minus 11 equals 0, or m squared minus 10m minus 11 equals 0. And if what we're trying to do is prove that this equals 0, we know that that piece can equal to this, or it can equal to this. In either case, what you end up with is a substitution. 10m, that's a 10m equals 8n, or negative 10m is equal to 8n. And so you either get m equals 8 over 10n or negative 8 over 10n. And so we can just write plus or minus right here. Then what you can do is use that substitution to rewrite the original problem all in terms of n, or vice versa. You could rewrite the original problem all in terms of m. So if we substitute in the 8 over 10, so we know that m is equal to that, so I can write plus or minus 8 over 10n squared plus 8n minus 11 equals 0. The plus or minus doesn't really matter here. Either way, you get 64 over 100 n squared plus 8n minus 11 equals 0. You can, from here, use either the quadratic formula or completing the square to get to a contradiction. I would suggest maybe multiplying everything by 100 to get rid of the fraction, or perhaps writing this just as a decimal, so 0.64 if we divided the 100 by 64 by 100, and just going through the quadratic formula here, and you should end up with some sort of a contradiction. So let's write that part out. So 0.64 and then 8 and 11. So 0.64 n squared plus 8n minus 11. So that would mean, by the quadratic formula, n equals negative 8 plus or minus the square root of b squared minus 4ac, all divided by 2a. And let's see where we get the contradiction here. Okay, so what is that? 4 times 0.64 times 11. So that's plus 28.16, and then 2 times 0.64 is 1.28. And I just assume what we're going to end up with is just something that's not going to be an integer. Let's see, what is the square root of 92.16? 9.6 equals negative 8 plus or minus 9.6 over 1.28. Let's see, if we do minus, we'd get negative 17.6 over 1.28. And if we did plus, we'd get 1.6 over 1.28. Well, that one is not an integer. So the last thing to check is, does the 17.6 divide by 1.28? And that is also not an integer. So it does work out here that assuming it's factorable over the integers leads you to a substitution. And when you do the quadratic formula, it leads you to a contradiction. And it works. And what I encourage you to try is take a quadratic that is factorable and see where this argument breaks down, because that's what I did to convince myself that it worked. Is I tried a couple examples where it was impossible, and I tried a couple examples where it was possible, and Klara's argument worked properly each time.